Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome back to the Fabrication Friday podcast. I'm your host, Joe Fairley, the owner of Ascent Fabrication and overall 3D printing enthusiast. Today, I've got an awesome special guest here from Essentium. Nirup Nagabandi here is going to be talking through from Essentium's inception of going from 3D printing and some microwave applications to their now high-speed extrusion 3D printer systems and materials. So Nirup, thank you very much for coming on.
Thanks for having me, Joe.
I was watching Essentium back in my early days of 3D printing in 2015, although I know there was a little bit more work that was done a little bit before that. Can you take us through kind of that birth of Essentium? I know there were a few people originally involved from who were students at Texas A&M University.
Yeah, absolutely, Joe. Yeah, so basically, Essentium started off as a materials company doing R&D for bigger companies. It was a bunch of material scientists, right? Blake, Elisa, Ryan Vano kind of started off the company in 2013. And by then, I think about by 2015, 16 timeframe, we wanted to be more product focused and not just R&D focused. That's when kind of joined hands with Brandon Sweeney, who has been working on nanotube infused interlayer bonding for like a high strength in 3D printed part, applying that microwave energy. So that's where about we started. Okay, 3D printing is where we want to kind of, establish and our roots and grow from there. So since that's about 2016 timeframe, and since then we have been very heavily focused on building and creating new materials into 3D printing world. For example, we introduced PCTG, a all-purpose, very easy to print material that is also skin safe, actually. So good for check sockets and stuff like that. And from there we kind of made a lot of materials and realized there's not any open source printer out there. And we started to kind of join hands with more of a machine builders out of California who were building semiconductor machines in their past life. So we built our machines from there and introduced our first high-speed extrusion machine in 2019. And there's a little bit of high-speed extrusion science and background, which we can go a little detail later on. Yeah. And from there, 2 years later, 2021, we introduced our dual head, basically the same frame of HSE, but with two heads. So you could kind of do multiple prints on the same build volume. And we still kind of stay strong with printer design, printer building, and material making.
Okay, so you've got basic it's FDM 3D printing, right? FFF FDM.
Yes.
That filament layer by layer printing, right? So you're not involved in any other 3D printing processes, right? Just FDM based?
Currently, that's our products, Joe. We have announced our metals program a year ago. We are about actually 15 months into our metals program, where we are using a blue laser with a wire to kind of, be more of a easier deployable machine kind of situation. But we are about a year or two away before we can introduce any beta machines out there.
Sure. Okay. Well, that's interesting to know too. I didn't know that you're into the metal side of things. I feel like metal printing is getting to be, quite I guess I wouldn't say saturated, but a lot more focused on recently, just because of some of the advancements that have happened from a couple of different companies, Desktop Metal, Markforged, looking at how quickly they can turn around metal parts, and even getting into the fused filament fabrication of metal,
Right.
with like Ultimaker making
Yeah.
some very green metal parts, right? So
Right. Right.
like how are you guys approaching the metal side of things?
Yeah, I think for us, for us, the logic was basically we are like, a big portion of our company is now also focused on machine building and
Right.
technology, right? But when we look at our growth prospects with our polymer printing, which is HSE or similar to FDM, FFF, our biggest customers live in aerospace and defense.
Mm-hmm.
When we kind of survey and kind of look at what they're doing, one of the things they want on the metal world is having powder-based or binder jet machines. That's all good, where they can do in their fabrication facilities in very well situated cities, right? But all of these guys have unclean shops at every forward location that they don't have access to.
Mm-hmm.
So from the survey from them, they all wanted a metal machine that they can get ready parts with minimal post processing and that could be deployed. Right? Can I put a machine in Hawaii? Can I put a machine in Arizona where I don't have a depot?
Right.
Right? So that's where kind of got us thinking. We kind of brainstormed a lot of ideas for about 6 months before we kind of decided what we want to do. And the logic was to kind of continue to improve our offering to our main customers, which is aerospace defense, by getting rid of powder, right? And keeping minimal post process. So that's where we kind of jumped into laser based wire
Okay.
solution. Pretty simple. You'll get very, very near net parts. And also we're kind of choosing our wire diameter very carefully where the resolution is as good as plastic printers. That's our thought process really. And yeah, once that is set, it's about, okay, guys, let's do this. So,
Right. Right. Yeah. I
yeah,
mean, with the kind of overhead costs that I've heard about, associated with some metal printing and just the equipment that you need, the time that it goes from being a green part, all the way through being debinded, that's definitely a lot to undertake, for especially some of these smaller metal parts that, might be, for the amount of hours that go into the printing process, might be cheaper just to have them, fabricated traditionally, right? But,
right,
with your point of being able to try to turn these parts around in a quicker fashion, on site, on their premises of wherever they need that part. I mean, that's kind of leveraging, the benefits of 3D printing there then.
right. No, exactly. That was the goal, Joe. Yeah, and actually, we also looked into kind of offering um, um, the filament based metal printing on our HSC. I mean, technically, it's an open source machine. You could buy this filament off BASF and kind of do it. Um, we have actually done it in the past in 2018. What we figured was it wasn't viable for customers overall. Exactly the reasons you just said. The
Sure.
amount of investment that you need as a downstream. Well, okay, if I don't need that investment, well, now I'm printing my green part, shipping it over to a different city, and all that logistics involved. So,
Right.
yeah.
Yeah, no, that's pretty neat to hear that you guys are into that. So take me through kind of how, the idea for this high speed extrusion, form of 3D printing came about, what all is involved in that with your couple machines.
Yeah, no, definitely, Joe. I think a little. I don't want to kind of sound preaching here, just because nowadays in the last year or so, there was like a couple more high-speed filament printers out there, so it's not like other people don't know about it now. But when you look back in 2016, 2017 timeframe, the standard was about printing about 30 millimeters, 40 millimeters per second. That was like a typical standard, right? And maybe on some materials, on a point to nozzle, maybe you're going 70. Um, but when we looked at it and kind of said, okay, we want to make our machine, well, we don't want to create another industrial machine that is a replica of other ones, right? So the two important pieces for us was one, keep it open architecture or open, source, kind of you could choose any material you want. So give all the levers to the customer, number one. Number two, make it next level. By that, okay, it should be at least 3 to 4 times the speed of what is there in the industry now. So as part of that, we had to kind of, there are three big components to it. One is the backend software. The two is the motion system. Number three is the nozzle dynamics itself. We had to kind of reinvent all of this at that time. What on the software side, the piece is now you're streaming a lot of data, and the controllers need to be processing and constantly making sure all the pieces are in the correct place at any given point of time. That means your controls need to be efficient. Your controls need to also take into the vibrations into account. Your controls also need to make sure your e-axis, nozzle temperature, X and Y and Z, bed temperature, all of this are kind of taking it 4 to 5 times faster than previously. So we had to kind of redo the controls architecture, taking into vibrations, everything into account. That was number one. Number two was the motion system. So when you're moving at this crazy amount of speeds, we are talking about 600-700 millimeters per second. Right? The biggest piece we were prospecting at that time was where, well, we don't want someone to replace belts and pulleys every 6 months.
Right.
Can you get high precision belt and pulley system up to 1 micron? Yes. But still, when you move that fast every day, you're replacing it. So we are like, okay, move away. What can we do? That's where we went into linear motors and linear drives, which was also fairly new. What that gave us is a gantry system that is maintenance free for 5 to 10 years, right? And also that can carry heavier loads, high momentum, because at these speeds, you're also carrying high momentum. Now, you don't have to, these are much stiffer, so you can be worry free of, would my belt sag over time? Would my head actually change as it goes from between to all of that? So a little bit of reinvention of gantry system there, which we really adapted from semiconductor industry, but it worked out well. The third piece was nozzle itself. So we had to melt a lot of material a lot more quickly.
Right.
So that was the other piece where we kind of introduced our trademark hosel, we call it, which is hot heated nozzle.
Yeah.
It was all in one piece. I think at the time and even now, most hot ends, and you look at it as like nozzle is a separate piece from the hot end, which is like the melting reservoir versus, and now it transfers into nozzle and that prints, right? What we did was we kind of removed all the mass from it and said, okay, we're going to have a single shank that's going to heat up. Also, it's going to be the nozzle. That way we were able to pump a lot of heat into the nozzle super quickly and in situ on demand. And yeah, we went with a very heavy heater, direct heating into the material. So these are the three big things. It was pretty challenging to kind of go through the iterations, and nothing existed out there. And we kind of rebuilt from scratch. So
Right.
it was exciting. But those were the three things we kind of the big pieces for us to make a HSC.
Yeah, I mean that definitely makes sense with, trying to control the heating a little bit more fine-tunedly. And then I guess my next question would be, well, what on the cooling side of things did you do to make sure that some of these materials are, printing at that high quality?
Yeah, so I think the good piece, the lucky piece for us, Joe, is I mean, we didn't do much differently really. We got a concentric fan, which seemed like a pretty standard on machines like Ultimaker back then, or Race 3D. I think they all had fans.
Sure.
We used a little bit more powerful fan to kind of demand more air. But lucky for us is um, and even at that speed, 3D printing still like the plastic welding was not enough to weld uniformly across layers anyway. So
Mhm.
it wasn't like you're keeping so much heat when you're printing, more than 3-inch parts, you're not keeping enough heat anyway. So it wasn't like we had to dissipate too much heat.
Sure.
It only became critical when we are doing like tiny features, less than an inch features, right?
Right.
Um, but again, I think we kind of took a very standard approach there, a little bit beefier fan, but other than that, yeah, we were I think still lucky. There was room on the heating side. There was less heat to be lost overall. So
Right. No, that's good to hear. And with again, is it a heated chamber as well? Can you tell me a little bit
yes,
about the printer specs, like the heated chamber, build volume, all that?
right. So our build volume is about 600 in Z and about 715 X and 515 Y. Um, One of the reasons the Y is smaller than X really is because we are trying to optimize the mass our motors can push, because our Y gantry is that heavy linear rail that kind of moves with everything.
Yeah.
So we had to choose like one axis to be bigger than the other, and we chose Y to be smaller than X. And yeah, that's about five like 750, 550 versus 600. It's a our nozzle goes up to 550 degrees centigrade. uh, we spec'd out our nozzles to go to 600 originally, but over time we found out really none of the materials needed to go to 600. So we kind of tabbed it in our software to go only up to 550. And then our build chamber goes up to 200 degrees centigrade. Same as our heated bed, which goes up to 200 degrees centigrade. Um, and the goal is to print any material, all the way from PLA, PCTG to PEEK and PEC and carbon fiber,
Right.
whatnot. So yeah, that's about the printer. And the unique thing with our nozzle is um, it's a sapphire tip, which means you don't have to worry about abrasion, printing long hours, hundreds, thousands of hours on carbon
Right.
fiber or glass fiber. It is gonna stay as is. So
Yes, sapphire. That some of these materials that we're getting into, in the high temp side of things are interesting to me because, in our day-to-day operations at Ascent Fab, we're really using a wide array of different printers, but most of them are using, just the standard brass nozzles, maybe
right.
a steel nozzle on a couple of them, but no, it's interesting to hear about all those different materials and processes that go into it in order to try to print at that high temp, high speed aspect. Are there
Yeah.
sizes of the nozzle as well?
Yeah, we are limited to at a zero 0.4 and zero 0.8.
Okay.
Two style. I think pretty standard industry there. Um, but yeah, you're absolutely right. When you print at that high speeds, even for neat materials without carbon fiber, your nozzles will kind of, change shape.
Right.
Um, so yeah, I think that was a other important factor when you talk about nozzle too. When you're trying to output so much, having that sapphire tip was another very important factor for us.
For sure. So
Yeah.
when you print in that heated chamber as well, one thing that I've noticed over the course of the last few years of printing and trying to print really durable parts that are going on to people, in your case, you guys are in the like aerospace industry as well. Do you find that like having that heated chamber, you would actually try to anneal the part either during and after printing, that you might like leave it in there and bake it for a little while before you take that print out?
Yeah, no, I'm already started to smile and laugh, Joe, because no, that is exactly one of the applications, right? I mean, I think I have our customers have used the build chamber very innovatively a couple times. One, I think annealing is a pretty standard, right? You can start to anneal as you print. There are pros and cons about it. One is then you get an uneven annealing, especially if your part is too big. Then
Mhm.
it's a little bit of a challenge because then you'll have different annealing thing. Um, I recommend typically users to kind of take one approach, either print amorphous and like use the chamber, leave it as an oven
Mhm.
overnight. It's not like you're coming at 12 in the night and kind of just program the software to kind of do an annealing cycle.
Right.
Um, the so yes, I think we are using that, and we have seen that basically it's an oven, and overnight prints just program the software to do that heat cycle, which is great. Other thing I've seen people use the build volume is to kind of, if one of the dryers was gone and they couldn't dry their material in time, and they just toss, as they're printing something, they toss, because of the big build volume, they toss a couple of their filaments in the bottom of the printer.
Sure.
So it's like, yeah,
Yeah.
well, as another print is going on, my spool for next day is drying there. I don't have to plug in extra um, electricity. So that
Yeah.
was out there innovative.
You got the triple purpose going on right there.
Yes.
You've got the printing, afterwards annealing and filament drying all in one system.
Yeah, yeah. No,
Yeah.
I would say it's a little bit definitely bold trying to kind of do the that. I personally wouldn't do it, but I think some of our customers have done it and been successful. And
Sure.
yeah, yeah. So
So tell me about some of these materials that you guys are using. What materials have you developed? What were those purposes you developed them? And then what are those industries you see that they're being used in?
yeah, absolutely, Joe. So right now, so the good thing is, like I said, we started off as a materials company. So materials is very much still in our DNA. We have about 44, 43 formulations of materials in our lab, all filaments, and which can also be, by the way, used in pellet printing, because these are designed to be
Okay.
3D printed. We don't offer pellets right now. We are looking into partnerships to see if there is any good interest. But basically, these are designed with a specific 3D printing flow in mind, everything. But we have on our website, if you go, you can find about 25 elements only, because some of them are exclusive for some partners and some of them for internal purposes, whatnot. Um, but our focus is to kind of, one is high speed, right? Because when you design the material for high speed, or when you design for 3D printing, you could also continue to print at a lower speed as well.
Hmm.
Um, Obviously, there is some nuances about kind of trying to make a material print across all range, but yeah, I think one of the pieces for us is 3D printable, high speed, and engineering applications really. So as part of engineering applications, a lot of our customers are into mold making. They use our carbon fiber filled high temperature nylon and our PPSCF carbon fiber to make molds. Um, I mean, these kind of last low pressure molding and a little bit of maybe up to 100 shots of injection molding. That
Hmm.
is one place our customers have been very successful. The other place that we're very happy about is we also introduced carbon nanotube filled ESD safe materials into 3D printing. And I think there is dual purpose to it, which we'll come to about in a little bit later, I
Sure.
guess.
Yeah.
Yeah, but so with the ESD safe, we have several customers in electronics contract manufacturing, and these are the guys that are kind of making phones, laptops, and they're kind of assembling all of these, right? And the good thing is, with the carbon nanotube based ESD safe materials, you're not getting any dust, but getting the advantage of ESD safe.
Hmm.
And the tricky part is you don't want to put the carbon nanotubes or CNTs throughout the whole material. Then you change the material properties, then might become brittle. Also, it is costly because carbon nanotubes are costly. We use our multi-layer filament technology, where we apply a very thin layer of carbon nanotube coating on our filament that is able to do it. And our material portfolio continues, but to pick few, I'm super proud of our PCTG material. It's really all-purpose. It's a skin-safe contact. It is not as moisture sensitive as all of our other materials. It can print on a $100 printers like Ender and RepRap machines to all the way to $200,000 machines like us. Super large print window, good chemical resistance, good toughness. I love that.
Sure.
I'm very proud of that. And very recently, we have introduced siloxane-based chemistries into filament fabrication. This is the first time. Basically, what this does is bring toughness to the material while also giving low temperature resistance, so they can last without becoming brittle, -20, -30 degrees centigrade. So, hey Joe,
Yeah.
maybe
Yep.
I lost you.
No, you're good.
Okay.
Back here. Yeah. Just skipped a minute.
Okay, cool. Okay. Yeah, so those are our materials are called Duratem. It's like a flexible Ultem. You can
Sure.
think of it that way. So that's why we kind of named it Duratem, kind of rhyme with Ultem.
Yeah.
And Altitude is the other material, which is also siloxane based, which is essentially a drone material for us. It can withstand -60 degrees centigrade when you go high altitudes, and also super tough and flame resistant. So yeah, a lot of engineering applications with a specific focus in mind, sometimes for ESD safe, sometimes for toughness, sometimes for temperature resistance. So
Yeah, that's a cool application for the low temperatures. Honestly, I haven't talked with many people who are, more focused on low temp resistance. When you get up into the atmosphere here. We did talk with Zach Burhoff though one of the last times here at Fabrication Friday on how he was printing, well, or he sending a printer and some files up to space, for one of the companies that he was working with. And
right.
or I can imagine, obviously, those low temps, you really need something that's going to withstand, that extreme environment. So that's pretty cool to see that you guys are, involved on that side of things as well. Talk to me a little bit more about these carbon nanotubes, because this is kind of what got me interested, in Essentium in the first place. Again, back in 2015, 2016, I was
Right.
finishing up my physics undergrad 2015 and just getting into 3D printing. And for whatever reason, the carbon nanotubes was it just stuck out to me. And I don't know if I was specifically looking for something like that, or just kind of happenstance came across it from, where you guys were starting out in that kind of time frame.
Yeah.
So the carbon nanotubes, how do you even get that into something that's going to be going into filament? And then, what does that application look like once you get it out there in the real world?
Yeah, Joe, I think, the reason for us to really get into carbon nanotubes was really some of the work done by our former colleague and, our former head of materials, Brandon Sweeney. During his PhD work, what he has done is kind of how to improve the interlayer bonding in 3D printing. And one way is basically, so plastic welding, similar to other welding, is like, to get the full strength, you're trying to heat up these layers to a certain temperature for a certain time. And if you try to do that in situ, there's no way. It's gonna be pretty challenging. So what he kind of came up with is like, hey, if you infuse with carbon nanotubes and stimulate with microwaves later on, they're gonna get that extra heat in there and kind of form a uniform bonding. That's how we came into carbon nanotubes. Really, the way to produce it is, one, you can kind of diffuse the carbon nanotubes into entire material, and then it changes the material properties, sometimes for some properties in a good way, some properties in a non-desirable way. But essentially, it's a very, I would say, a little bit of a trade attached to it, but not too complicated to blend carbon nanotubes into the polymer of choice. There's a little bit of art there, but it's most blenders and most plastic manufacturers can do that with their blenders. But the tricky part is, how do you not get it across the whole material? Because now you change the properties of the full material and also price. So that's where we created our multi-layer technology. So what happens is, as you're extruding filament, we have a external die that wraps around the filament that is coming out of our extruder, and that does a small coating just on the top of the filament. So that way we are able to just do the carbon nanotubes on the top layer of the filament. And now as you print it, the good thing is there is not too much mixing in a 3D printing nozzle. It is not a heavy turbulent or a heavy, super high flow system. So most of the coating and the layers kind of come in the same architecture, right? The carbon nanotube layer kind of stays outside. Also, it is more viscous, so it doesn't want to go inside anyway. Once that happens, you have this almost like a sandwich, right? At a layer by layer, it's like a neat material, carbon nanotube coating, neat material. Now you apply microwaves to it, it's going to heat up and kind of fuse all over. That was his kind of research. We kind of adopted and scaled it up into filament making, all of it. And also we kind of started to build our printers with microwave. Then we quickly figured putting microwave in a metal cage is not a great idea. So we kind of pivoted and found still essentially what we're trying to do is put electromagnetic energy there, right? Like carbon nanotubes can absorb this electromagnetic radiation and turn it into heat. So instead of microwaves, we kind of moved into radio waves, which converted to a plasma. So that's how we came about. We developed our underhead plasma system that prints along with the nozzle and kind of, heat up the layers as they go, give that extra heat. And yeah, we're still continuing to develop that technology. A lot of physics involved, too much too much controls need to be figured out. So it is still in our lab. On a day-to-day basis, we still see good results from it. We need to figure out how to kind of, package it into a way where we can put in people's hands yet. So
Sure.
that's the story of the carbon nanotubes.
Yeah.
Yeah, that was the main reason. Eventually, we found other use case, which is ESD safe.
Right, right. No, that's really, really neat though. I mean, having that, application of those sandwiching the layers, we've kind of found a similar thing when printing with the Mark Forged, continuous fiber fabrication there, printing the actual continuous fiber strands into sandwiching between layers of nylon. So I can imagine how these carbon nanotubes would be placed, in a very similar fashion. Yeah, when the physics geek in me is just like screaming right now, where come on, carbon carbon nanotubes, that kind of micro scale going into helping to solidify a part, and then having some external either heat source or microwaves like you mentioned, being able to really combat this Z layer bonding issue that that is inherent to the process of what we're doing, right? So
Right.
it's interesting to hear that you guys have kind of tackled that from a couple different ways here.
Yeah. Yeah, I think, thanks, Joe. I think really it's about, not only machine, but also material machine combination, really. And I think the first use case for us actually for this was prosthetics. You know, because when we looked at it, the reality was that at the end of the day, even if you get isotropic bonding for very demanding applications like um, you know military or airplanes or trains or big things like that, it's going to take decades, people moving from metal to plastic. So we were like, okay, people are already doing, prosthetics in the, check sockets with, 3D printing plastics and whatnot. Why can't we do definitive sockets as well? Well, if you can figure out the Z-layer bonding, maybe this is the right use case. So that was one of the first motivations as well to kind of create this system and combination. So
Sure. Yeah, I mean, with prosthetics and orthotics for that matter, there's those issues of Z-layer bonding, the issues of what orientation do you print the part at to try to optimize that structural integrity as well. And then with the print orientation, do you instigate other potential 3D printing problems like warping that's ensued, or
yep.
other issues that might come up when you're actually trying to physically print these parts in the most durable way possible by this technology, right? So
yep.
That's everything that we're looking towards, in the prosthetics field and orthotics, is trying to make these, end use devices for people. Actually, you'd be happy to know that I have used your PCTG before, printing test sockets,
Yeah.
just a couple years ago, and yeah, printed beautifully. Was very nice and crystal clear. And since we've been involved with a lot of different companies now and different printers and different materials, but everyone has this kind of preconceived notion in the prosthetics field of carbon fiber. Carbon fiber is the one material to go to, right? Like, so in some ways, when I look at carbon fiber, I see, well, sure, it might be, when it's traditionally fabricated and laminated, it has amazing strength properties and very lightweight, right? But one thing that I see with carbon fiber is that it's inherently extremely stiff. And so we might not want some of those stiffness qualities while trying to gain the same or similar, strength properties. So, what is your take on that? With, we're using carbon fiber, we have HPMJF printing, typically using PA12 or PA11 nylon for these, more definitive style sockets that are actually able to go out on people, for more than a year for sure, up to 3 to 5 years is really that kind of timeline. So, what's your take on that with your past involvement in the prosthetics industry?
Yeah, no, I think obviously I don't have as much deep insight in the industry like you, Joe, but I'll kind of talk about it from the material perspective because I'm that's what I'm more aware of is. So we've created about 4 materials that we kind of obtained skin safe certificates for prosthetics and orthotics, right? Our PCTG, our carbon fiber nylon, and our carbon fiber PET, and our TPUs. The goal, though, I think one of our carbon fiber nylon, especially what we call it as PSCF, is formulated, and actually we have said, okay, it needs to be a little bit ductile as well. So the good thing is, if you formulate your nylon inherently likes moisture, no doubts about it, which is not good if you want to print with it, right? Like just when you want to print with it, it's not good. But if you optimize it enough where the absorption rate is lower, but it can absorb more overall, right? Hey, my saturation moisture is 5%, but my intake rate is very slow. If you can kind of, formulate your material that way, that is a good at both worlds, because before printing, you can maintain your filament at a very low moisture because it is not uptaking fast. You print it with it, then you can do a hydration process, which is a fancy name to soak the pod in water at a certain temperature for a certain time. And now it has absorbed and saturated that 5%, 5.5% moisture, making it softer and ductile. And that's the approach we have taken on our PACF, where it's a slow absorption, high saturation moisture, material. Good for printing, but also after printing, you can do a hydration step and lose some stiffness on it. That is one way, I think. So if you have not tried out PSCF, take a shot and see. The other good way I'm thinking is we've recently been working with a company called Limber. They're taking this approach of design of the prosthetic itself, which is kind of dealing with some of that stiffness component, right? Can you design your ankle or the shape of the prosthetic itself where it is more, the design itself gives that more ductile facility overall. So now your material property becomes less relevant and your design feature kind of stands out. So that's another important, I think, interesting and a new take, I would say. But yeah, I think that's as far as I can talk about on that.
Yeah, I mean, you bring up an interesting point there, though, with the uptake of the amount of moisture that these materials absorb, over time. I don't know how much you can speak to this, but how do you actually go about that process of formulating the compounds, those plastics to to behave differently like that?
Yeah, no, I could talk about it, Joe. I think it's not secretive. And the specific formulation is, but I think the process basically, so we have very limited in-house chemical synthesis. I'll say we have a lot of knowledge about it. So we work with our supplier partners who have these labs. Actually, what we do about it is like, hey, the reality about all of this is how much of the chemicals and atoms that like moisture are open, right? And how quickly are they open? So it all depends. The polymer has two things: the backbone, which is like the long chain, and then it has branches, which is how heavy can you get your molecule without being long. So trying to optimize your branching and back chain length is number one. Number two is, also kind of how much do you have open, right? Like,
Sure.
okay, if you want, so for example, very theoretical, right? Very theoretical here. Well, you have a big chain with 20 branches and polyamide, right? Nylons are polyamides. Amides like water, right? So let's say each of this branch has two open amine groups. And if all the branches kind of stick out, then they want moisture immediately, right? Because they're all sticking out, they want it. Instead, if you can make that branches kind of stuck inside, now they're not easily accessible, but they still will like moisture at some point. So that is the trick to kind of slowing it down. But if you close up that amide group, then it doesn't take moisture. So it's about having as many amide groups open for, moisture uptake, but also have them tucked in instead of facing outwards. So it's a stereochemistry and a chemistry problem. We typically kind of go back to our suppliers, talk with them, and ask them for different formulations. We work with them because we don't have in-house synthesis.
Right.
But that's a typical process.
Yeah, with that, my initial thought would be, okay, so the longer you make your chain, right? Does that have any correlation to that end material being more flexible or more stiff?
Yes, your chain length will have a big effect on your end properties, but also it will have big effect on 3D printability. So there is a sweet spot in terms of how much you want to branch versus how much you want to chain to have an optimum flow value, which in turn has effect on your final strength.
Right.
So you don't want it too long. Then you're kind of then you kind of get into that. Well, it's gonna be it's not ideal, right? I mean, it's not going to be ideal for 3D printing for flow perspective if it is too long. But also you don't want it too short, then you lose your properties. The longer it is, generally it is stronger. You can kind of correlate that way, and it's very general basis. But also, the longer it is harder to flow.
Okay. Yeah,
So you kind of want to optimize it.
that's interesting to try to conceptualize and think about, okay, so the materials that I'm using, my day-to-day printing, the TPU, PETG, the foaming TPU, Vario short,
Yeah,
like how all of these, you do have to kind of have this like chemical and material science background a little bit if you want to try to optimize, some of these prints that we're getting, to understand how mechanically these layers are actually bonding together, and that's something that we're trying to to help and push forward here, through the podcast, as well as just kind of generally increase this level of education around, like, okay, what are we actually physically trying to do with it's not as simple as just putting material into the machine and hitting print, right? Even if you do have good print settings that are already optimized for a specific device, they might not be so great on the next device.
right.
Depending on the print layer times and everything like that. So it's just interesting to try to conceptualize that, and for some of our listeners here who are, either tinkering at home with small desktop printers, or also involved on the very industrial side of printing like you are. Just a interesting, way to think about it, that I think is going to instill some things to think about for sure. When someone goes to buy their next spool of filament, and maybe they're going to Essentium, or maybe they're, considering some of those, chemical properties of what they're trying to achieve. So that's pretty neat. With that kind of development that you've had at Essentium so far, can you touch on a little bit more of, like, okay, where's Essentium going from here? Like I just heard from Zach Burhop again that 3D Fuel
Yes.
has been now involved in the company. I haven't used any of their filament myself, but can you elaborate on that a little bit?
Yeah, absolutely, Joe. I think one core pieces for us was, making in USA for Essentium, like, everything we design here, make here, and all of that. And when you look back at it, we have been on the very industrial side of things, even though we have capabilities that can cater to the broader range. And as I think last year or so, we kind of thought on the material business side of, okay, what are we generally, where are we at on the basis? The thing that stuck out to us was we have very, very few customers who are on the home printing side, very few customers on the
Sure.
enthusiast side that are kind of looking at it. And when we look back, well, one of the things was we are super focused on this engineering grade filament. So which means two things. One, it is pricier. Two, it is also, you need a little bit of upgraded printers to be able to print them. So that's where we're like, well, we have so much more knowledge to offer. Why don't, like, but when you look at it, 80% of 3D printers are actually the guys who are, doing it on their own, the home printers or hobby printers or the makers. Like, I mean, all of this knowledge we're developing, all of this things we're doing, we're not able to cater to the bigger community. Like, okay, how can we solve this? And the factor for us was to then kind of, start getting into this community of all the makers. So as part of that, we looked at, okay, we don't want to do it by ourselves. It's basically in reinventing the wheel, probably other people have already done. So when we looked at it, 3D Fuel struck our piece where they have done everything in-house. They have done all USA made. They've sourced materials in USA, which kind of stuck in the DNA of what we are doing as well. And the other piece they have been very efficient that we couldn't figure out was the colors. They offer 40 different colors on PLA, and we have three. So I think that's also the other different piece that we never envisioned or thought about, because in the engineering world, the functionality was the biggest piece and not focusing on colors as much. Well, I mean, some of our customers want colors on the engineering side as well, but they're not asking for 20 colors, right? They're like, okay, can you do 2 different colors, 3 different colors?
Sure.
They just want, I want a difference between line 1, line 2, line 3. That's it. So that's where it's like, okay, that's when we actually didn't look any further. We engaged with John at 3D Fuel. We brought him in house, and then partnered with them, and now we're tapping into the maker world, and yeah, we're very happy with it. The biggest thing for us is to kind of apply, bring our knowledge, and bring our material manufacturing expertise to all the makers, because that really is constituting 80% of the industry right now, which we want to kind of hey, yes, what's the point of all this knowledge if you can't use it to the people that are using it? Okay, so
Right, exactly. No, I've kind of started to take that approach as well. I love the aspects of trying to stay as local as we possibly can. I think 3D printing, the development of it, from materials and hardware standpoint, is still pretty much in its infancy here in the US, at least. It sounds like the rest of the world has been very more so involved on, that kind of development for materials and hardware. The couple printers that I have, shown behind me here, those were both made and sourced, in the US. So that's nice to see more companies, staying more local. I know, again, I'm bringing up Zach again because we had a great conversation. He was so excited. And I loved his excitement around, being able to source filament, close by, with it being right down the road from him, close by, being able to maybe walk off the street and grab a couple spools of filament when you want them. That's been something that I've been trying to start to build here at Ascent Fab as well. We're a filament reseller for 4 different companies now, and
nice.
That side of the business is growing quite rapidly, and that's exactly what we're trying to do with trying to source good materials that we know work specifically with our workflows, and they've been repeatable in terms of diameter and coloring and stuff like that. So I do appreciate that approach, and definitely have to get my hands on some 3D fuel filament, and more Essentium filament for sure.
Absolutely, Joe. I mean, let's connect and make sure, but we'd love to kind of, one thing we're doing at our physical store here, as it comes into full swing a little bit, I mean, we just started that, right? But we are also going to offer like a factory tour, because we literally make it behind the door. I think once a quarter or so, we will kind of, do a sign up and let the local folks come in, walk in, and see, basically like a brewery tour or chocolate factory tour. But can we make it as interesting and kind of, look at the intricacies of making a good quality filament to the outside world? So we're very excited about that. If you're in town or if you want to make a trip, you're 100% welcome to drop by, and we can show you all we do.
Yeah, thanks. I'll definitely have to take you up on that sometime. I know Form Next was just in Austin, right? So
right.
I'm assuming you were at that show. Like, were you, and how did that go?
Yeah, so I'll say I was at that show, and I would say, like, I think my expectations were looking at the AMAG and the big shows, and the Form Next in Germany, which is like the biggest show in 3D printing you can go to. And then this was very small, right? It was a half a hall with about 30 exhibitors, 35 exhibitors. So it was a little bit, when I walked in with these big expectations, it was underwhelming for me overall.
Sure.
But I think the level of interaction was very high quality, right? Because it's the first time that it's possible that not many people were willing to kind of say, put a booth out there.
Mm-hmm.
And also probably everybody used up their marketing budget in AMAG and Rapid earlier in the year. So I can see why there were less number of booths there, but it was really good level of interaction. The quality of interaction was nice because it was smaller number of booths, so there was like more time for you to kind of go deeper in conversations with folks out there. So,
Mhm.
which yeah, at the big Farm Next in Germany, there is a lot to unpack. So you're kind of in a hurry to kind of jump like booth to booth to kind of make sure you touch base with everyone. So you're kind of in a hurry. But
Mhm.
here, I think that kind of enabled to like, oh, you know what? I'm gonna spend a little bit more time talk deep stuff. So
Yeah,
it was nice. Yeah,
nice. No, that's
yeah,
good to hear. With myself being at the American Orthotic Prosthetic Association
yeah.
National Assembly last week, I would say I had that time to go around. There weren't too many vendors, and I feel like people are still coming back around after COVID to being open to traveling. And if one of these conferences offers anything virtually, then they kind of question that and say, well, do I have to go? What does that travel and or for companies marketing budget look like? Yeah.
Right.
The show was pretty good, I think, from some attendance, and there's a lot of interest in the digital space. From the company standpoint, I feel like a lot of people trying to get into this market of prosthetics, who are either 3D printing companies or software or 3D scanners. Um, it's interesting to just be on that kind of front, forward facing to those specific customers, the clinicians, for where our industry is headed. I definitely think there's a lot more room for growth in that application process of different printers, different materials. And then getting out to some of these conferences is definitely well worth these clinicians' time too, because they need to see what is the latest and greatest out there, and be able
Right.
to experience things, just in the 3D printing industry. I think for the certified prosthetist, orthotist, and the company owners listening to this, I definitely urge you to go out to maybe some of these 3D printing industry conferences as well, to see how other people are approaching some of these same problems that we're typically having with printing some other different devices here in this field. It directly relates to what's going on in under other industries.
Absolutely, Joe. Very well said. Yeah, I agree with what you're saying, and I think even the like as an extension to that too, I think most likely probably people can take inspiration from your shop and what you're doing, and also and it is not as cost upfront cost as it used to be in the past, because nowadays there's printers in about that could do at least the check sockets, if not the definitives, under a $2,000 printer.
Right.
Really, I think there's really a lot of upside to it. I mean, one of the biggest things as I talk about upside is in collaboration with Rotary Club in Dallas. I mean, everything was put together by them. We were just partnering and helping them, I guess. Was They had this project to print about 100 sockets for kids in Tanzania,
Hmm.
um, like because of all the different things going out there. I mean, they don't have access to clinics, they don't have access to medical, even the government doesn't have much resources. So what the Rotary Club of Dallas did was kind of put together a 3D printing program to pack a printer, amount of filament, and a software that, like you're talking about scanners, the software has a simple scanner. It
Hmm.
scans the kid's legs and, turn it into an STL and throw it onto this printer. We feel happy and fortunate to kind of be part of that project where we contributed our filament, and we recommended printers for them. But yeah, it was as simple as that. It wasn't much budget, right? It was very small, and they were helping. I think on the first phase they helped about 100 kids, and so yeah, again, that's one side of it, but it could be as small investment as thing to get started and then go from
Right.
there. So
Yeah, it's definitely easy to get started, and then you get down the rabbit hole of all these different exciting things like carbon nanotubes, and then
yeah,
then you're off to the races and on to another level.
yes,
So I appreciate, what Essentium and you guys are doing over there to kind of push forward some of these, material science aspects of, the high speed extrusion, how we're printing these different materials and then what's actually going into them. So, nicely done there. I'm excited to continue to, watch what Essentium is doing. And, absolutely, if I'm ever out your way in Texas, I'll definitely reach out and, try to get the full tour there. That'd be pretty neat.
Absolutely, Joe. You're welcome anytime. So.
Yeah. Well, anything else for our listeners? And if they'd like to get in contact with you, we'll have stuff in the show notes here to reach out. But anything else there for the for the listeners?
I think the statement you said about, hey, there is a lot more upside for the industry. I think really that's it. Really, there's a lot of not only Essentium, right? There is other companies that are pushing the boundaries, trying to kind of do more fundamental knowledge out there. So I'd encourage everyone to continue to jump in 3D printing, because the entry point is nothing, and go from there.
Mm-hmm.
And if at any point, if you are interested in like more engineering stuff, or even like want to get into the real basics, feel free to contact me, or any of my team members too. We would be more than happy to always talk about the fundamentals of 3D printing. So
no, that sounds great. Thank you very much, Nirup, for coming on the Fabrication Friday podcast this week with us. I appreciate your time and looking forward to some of the response here from the listeners. We appreciate it.